All right, so we have chapter 16. We looked at the first part of chapter 16, which was just looking at probability distributions and finding the mean and the standard deviation of those probability distributions. Brenda's asked to do problem number 9. We're going to look at data set A. And so let me just copy it down here for us to look at. So we have the random variables, and then the probability of those variables happening is 10.3, 20, 0.5, and 30.2. So just as a kind of a reminder to find the mean, it's simply the random variable times the probability and then the sum of all of those. You can also use your calculator for that. Remember, you can plug, you don't remember. You want me to show you how to do it on the calculator as a reminder real quick? So all you have to do is go to your list, stat edit, okay? Clear out anything that's in there, and we'll plug in our random variables 10, 20, and 30 into list 1. The probability of those goes into list 2. And we can go to where from here? Once you've got the data entered, where do we go? Stat edit, 1var stats, actually stat calc, right? So stat calc, 1var stats. And we have to make sure of what? The frequency has to be where we put our probabilities, which we did it in list 2. And then we'll calculate it, okay? So the mean happened to be 19 here. That also produces the standard deviation, which is 7. But I think I did tell you in your homework to do it by hand, didn't I? Okay, so I did. So that's what you should do. So if you looked in the chapter when you read it, okay, how can I get that number 7? Because 7 is the standard deviation, right? All right, so if you look at the formula for standard deviation, it gives you this. Well, it gives you the variance, doesn't it? And then once I have the variance, what do I do to get the standard deviation? I didn't hear you, I'm sorry. Say it louder, Judith. Square root. Okay, yes. So we're going to have the sum. So we're going to be summing some things. X minus the mean quantity squared times the probability of that happening. So we had to find the mean first in order to do this problem, which we did. The mean was 19. You found that in 1A. So what we're going to do here is we're going to find the standard deviation. We're going to say the variable minus the mean squared times that probability plus, because we're summing all of these together, correct? And that's going to, if we keep going here, we have 20 minus 19 quantity squared times its probability of occurrence plus 30 minus 19 quantity squared times its probability. When I plug this into the calculator, I don't get the standard deviation. What number is it going to produce for us? The variance, okay? And we're going to talk a lot about the variance today, and it's an important number to work with mathematically, and you'll see why in a little bit. But what number do I get here? 49. And even if you didn't know, couldn't I just square that number and know it would be 49, right? So the variance is going to be 49. We want the standard deviation, which is 7. Question?
Say like there was another number like 40, and then the probability of x was 0.3. So you just do plus minus 19, but squared times what number I say.
It's the same thing. The only problem I have with what he just said, what if there was another number added on? Would you just consider the same pattern? Sure. But in a probability distribution, what do all the probabilities have to add to be? So I know I have all the outcomes, right? Okay. Brenda? Better? Okay. On your next quiz that you're going to have on chapter 16, I am going to ask you to do the standard deviation by hand. But all you have to do is show me the formula, and your calculator does give you the answer, so you have a way to check yourself. But I will ask you to do one, just one, by hand. Okay? And it'll be small like this. It won't have like lots of numbers. I'm actually surprised no one's asking to do any of like the spinning the wheel problems and the gambling problems that you guys had to do probability distributions for. Did y'all have any of those to do? No?
We had the cards, number 3.
The carnival. Oh, well, you didn't have to do the evens. That's the problem. What about for number 5 or number 7? 5. 5. 5 it is. All right, let's do one more. We'll do problem 5. I am going to assign actually we're going to do number 6 here together in just a second, so we'll look at that one. But number 5, it says a couple plans to have children until they get a girl. That's what Mrs. Macker did too. Boy, boy, girl. Okay, good. But they agree that they don't have, they will not have more than 3 children, even if all are boys. This is like my life right here, okay? Assume boys and girls are equally likely. Create a probability model for the number of children they'll have. When it says to create a probability model, what is it telling me to do? What up here is a probability model? This table, right? Because that's what I'm looking for. So just keywords, probability model, what am I doing? I'm creating this distribution, okay? So we know we have to figure out what all the outcomes are, and then the probability of those outcomes, okay? So it does say the probability distribution for the number of children they'll have. So how many children are they going to have? What are the possible outcomes on the children? Well, what's the minimum number of children they're going to have? Well, they're going to have 1. They said they're going to have children, right? I believe. Let me double check that. But yeah, they're going to have, it says they've agreed to have children. So they're at least going to have 1, because if that first one's a girl, boop, done, right? So we know we have 1 outcome. Is it possible they'll have 2 children? The first one could be a boy, the second one would be a girl. Is it possible they'll have 3 children? Mrs. Mackert right here. I'm going to highlight myself because, I'm happy with that. Okay? So how do I figure out the probability of each of those outcomes occurring? Well, what's the probability that they'll have 1 child? Yep. How'd you get that, Devin? Yeah. And it's actually not, believe it or not. Like it's a little bit off. Like it's like 49-51, something like that. But anyway, yes, I agree. So we would say 0.5. If we're talking about a slot diagram, I have a 50-50 chance of getting a girl on the first try. Okay? So I agree, 0.5. What's the probability of having 2 children? No. Oh, wait, hang on. How'd you get, that's not 0.4. How'd you get that, Brenda? Not divided by 2, but your answer's right. Process, though. 0.4 is not right, honey.
There's a 50% chance that you won't get a girl on the first one, so you're going to try and get a girl on the second one.
Think about a slot diagram, right? If I'm going to have 2 children, the first one has to be a boy because I didn't get my girl, right? The second one has to be a girl because I got my girl. So it's just 0.5 times 0.5. Okay? 0.5 times 0.5 is 0.25. Oh, you said 1/4. I'm so sorry. I thought you said 0.4. I'm so sorry. Yes, Zachary, you're like 1/4. I've said it 5 times, Mrs. Macker. Yeah. No, you're right. 1/4. 0.25. I can't hear. True that. All right. Number 3. Number 3. I don't have to do a whole lot of math here. I could do a slot diagram and go, I know it's got to go boy, boy, girl, right? But don't I also know the answer is 0.25 just by default?
Yep.
Why?
Because it has to equal 1.
They have to, the sum of the probabilities has to be 1. All right, so I've got the probability distribution. There's A. That's what they were asking you to do in Part A. Part B says find the expected number of children. When I say expected number, what's another way to say that? Expected value, what's another way to say that? Mean. Okay? So when we're looking at expected number, expected value, I'm looking at mean. So I am going to do the same thing I did before. Now I'm going to say 1 times 0.5 plus 2 times 0.25, et cetera, et cetera. So the mean is going to be, according to the book, 1.75. Do I ever round that? Never. Okay, so when we talk about averages and expected numbers, I fully expect there, look at that. I fully expect there to be decimals in my answer because it's an average talk. We're not going to round it up to the nearest child. It's not like they're missing an arm or anything. Okay? Go ahead. Right, so you're trying to put it in context. When we talk about averages, we're not going to talk about a full child. You have another way to say that. Let me think. I can't think right now. It's not a probability. It's a mean. Over time, on average, if I were to look at many people having children, okay, and I was to look at people that had 1, 2, or 3 children, I'd only have to look at those people. I would expect, no matter if I had a group of 50 people, actually probably be more like a group of 200 people that were in this situation, the average number of children, if I said, okay, Amanda, how many children do you have? 2, got it, all right, and we'd go around the room, the average would be 1.75. The average of the average of the community. It's not like and the unit is kids, okay, but we're not talking about one person having 1.75 children. We're talking about the group. The average would be 1.75. Is that a little bit better? I know you're worried about the arm missing. I get it, but it's not that. Okay, standard deviation. Can we do it by hand? We should be able to at this point, okay? So it's just 1 minus 1.75 quantity squared times 0.5 plus, and continue on from there. Then you would take the square root, right? And the answer according to the book, oh, it didn't ask for it. Oh, never mind. Okay, sorry. So C asked a different question. I assumed it was standard deviation. Find the expected number of boys they'll have. Well, that changes the game. Changes the game. Does it? Is the probability distribution the same? You have to make another table. That's exactly right. So let's make another probability distribution just for the number of boys. This was for the number of children, right? Totally different question. So probability distribution here for boys. So I just write here, this is for children. This is for boys. What are the outcomes? I can have 0 boys. Would you agree with that? All right, because I can have just my 1 girl. Can I have 1 boy?
Yes.
Well, that would be this one, right? And can I have 2 boys? Okay. So that's what changes about the probability distribution. Okay, sorry. Thank you. Yes, that's correct. Good. All right, so how do I find the probabilities here? 0 boys would be, because you got your girl in the first try, right? All right, keep going. So nothing's changed until we get here. The probability is not 0.25. How'd you get that? Remember? Who can remember? Do you remember? He doesn't remember. AD, how do I get the probability with number 2, or for 2 boys? How do I find the probability for that? You don't know? All right, so be engaged. Look at me. Think about it this way. If I know I have 2 boys, that means the third one was a what? Okay, so that means here I have 2 boys, and I got my girl. Would you agree? What's the probability of all of that? Multiply them. You had your calculator. What's the probability of getting a boy? Okay, so what's 0.5 times 0.5 times 0.5? Huh? 0.125. How about here? If all 3 are boys, isn't it also 0.125? Right? Okay. Do they all add up to be 1? We always want to check that. And I encourage you to check that because sometimes you're forgetting some possible situations, okay? And that happened actually with quite a few of you on the midterm exam. which we'll talk about at a later date. Okay? But on the probability situation, quite a few of you forgot a situation, and it didn't turn out to be the correct answer. So a way to check yourself when you have a distribution, add them all up. Okay? Ready to start the new stuff? You were given a sheet, or you should have gotten one. If you didn't get one, I don't know if Judith got one because you came in late. Good. This is what I'm looking for. Because these are all word problems, I decided to print them out ahead of time for you. Okay, so this is kind of like your slideshow. So you can just do the work right on here and go from there. Okay? You're just a mess. All right, so late. Tell Miss Madden that, you know. All right, ready? Everyone have one now? You ready to go? You going to be ready? Do you have 5 a.m. wake-up call this morning? Guess what? I'm ready. All right, here we go. So when you were reading chapter 16 to do your homework, because, you know, Isaiah said you had to figure out what they were talking about, right? And so he did it, so that's good. 2 thumbs up. We talked about different ways to combine random variables. Up to this point, all we've done is talk about the probability of having a girl, the probability of having 2 girls, the probability of having 3 girls. But what about if I talk about the probability of having a girl and a dog? I now have I can have a probability distribution for the girls. I'll have a probability distribution for the dogs. And then I have to add them together somehow. How do I do that? Okay? So it's kind of, we're going to take a probability distribution or a situation, and we're going to manipulate it in different ways. We're going to multiply, in this case, or add by a constant. What happens when I do that? Okay? There's an equation that we need to follow. And by the way, they're all in the back of chapter 16. Like, you know, in the back right before it asks you the vocabulary and stuff at the back of the chapter, there's a section that has all these formulas, but they're also on this sheet. Okay? All right. So if you have a highlighter, might be a good chance to use it here since the notes are printed for you. I've got some on my filing cabinet. Help yourself if you want. You all right? Okay. I'm worried about you. Are you sick again? No? Just cool. All right. If you add or subtract a constant to a random variable. Now, when I say a random variable, what am I talking about? What we just did. Okay? We have to define it in a certain way, and we'll be defining what the random variable is in each of these cases. But if you take a constant and you add or subtract it to it, you're simply going to do the same thing to the mean. Okay? This is important. Any constant added or subtracted, you also add or subtract to the mean. Okay? Think about it, and then what happens to the standard deviation? Well, the notes say it doesn't change at all. Okay? It actually stays the same. And this kind of makes sense. Think back to the very beginning of the year when you guys had to do that summer assignment. Remember that? And we added a constant to everything. Remember how we did the little whiteboards where we had like a little human number line up here, and I had everybody, and we added the same number, and we had like a group of people. I said if we add the same number to everything, like everyone change your number and add 4 to it. What happened to this group? They moved 4, didn't they? So the mean moved up with it, didn't it? What happened to the spread? It stayed the same. So that kind of makes sense, doesn't it? If I add or subtract a constant, the mean changes, but the standard deviation does not. He's like 5 minutes behind. Come on now, Brian. Oh, for your sister. Oh, he's being sweet. Like, all right. So if you multiply by a constant, okay, so let's think back to the human number line. Okay, if I multiplied by a constant, what happened? Remember that? It's spread out. So let's think. It says you're going to multiply both the mean and the standard deviation by that same value. They both change. And if you remember back to the beginning of the year, we already know that. It's kind of like a review. we did it with numbers as opposed to random variables. Same thing though, okay? Same principle behind it, okay? So let's look at an example, okay? Consider a dice game where you get no points for rolling an even number, and a 3 or a 5 is worth 5 points, and a 1 is worth 50 points. Okay. How am I going to find the mean and the standard deviation? Before I can even start, what should I do? What did we do in the last two things from homework? What did we do? Make a probability distribution. Okay, so we're going to do that here. Let's define our random variable. We're going to call it x. And what is it? What are the possible outcomes? How am I defining it? It's what? Those are the possible outcomes, I agree, but the random variable is described as the amount of points you can get. Okay? That's really what we want to do. So we're going to call that, we're going to write that here. We're going to call that, it's the point value. And you really want to get into the habit of defining it. What actually is it that I'm looking for? Because you can define things in different ways. Maybe it's a point value. Maybe it's the outcome on the dice. What am I really looking for? Well, we're looking for the amount of points I can get in the game. Okay? So, what are the possible outcomes now that I know it's not 1, 2, 3, 4, 5, 6? Those aren't the outcomes because those are what comes out on the dice. But I want the possible outcomes for the number of points. I can get 0 points? One point? No. 5 points. And then, what's the other outcome? 50 points. Good. Okay, so those are my possible points in the game. I now need to find the probability of those things occurring. Okay. Now what? What's the probability of getting 0 points? Well, we have possible outcomes on a dice. 1, 2, 3, 4, 5, and 6. I'm going to highlight 5 points would be a 3 or a 5, right? And then the 50 point is a 1. Everything else gets you nothing, okay? So that would be half of the outcome, so you said 0.5, right? Good. Excellent. What is the probability of getting 5 points? 2 out of the 6, or 1/3. Okay, good. Let me go ahead and leave them as fractions, because I don't want to round. 1/3 of the time, 2 out of the 6 chances, you can get 5 points. And then how about the last one? 1/6. Do all of these add up to 1? 3 6, 2 6, 1 6. They add up to 6 6 or 1. Okay, so now that I have my probability distribution, let's find the mean and the standard deviation. You are okay to do it on the calculator right now just for speed. So plug it into list 1, list 2, and plug it in and find it for me.
How did you get the 1/3?
Okay. The highlighted ones, I've got 2, right? And there are a total of 1, 2, 3, 4, 5, 6. So 2 out of 6, or 1/3 of the time. Okay, good question. So find me the mean and the standard deviation. Plug it in. I won't require it by hand this time. Practice being able to use it. Come on, Hunter. You're not exempt just because you're in the cushy chair. Oh, you're still doing it. I thought you did it. I thought you were trying to cover it up. Being secretive. Trying to hide it. Okay. Does that seem reasonable? Does your mean seem reasonable? An average of 10 points? Yeah. What is your expected number of points? 10. Good. A different way to say mean, right? So we have 10 possible points. Or not possible, but at a mean of 10. Over time, on average, you will get 10 points. Question? No. Okay. Standard deviation? Give me some kind of gauge of what you want to round that to. 2 decimal places, 3 decimal places? 2 is probably reasonable. So 18 point what? Okay. Definitely not 18. You want to not round it to a whole number. Okay, fine, good. Now, here's where what I was highlighting earlier comes into play. What if I change the game? And I say, okay, people really aren't winning. They're not going to play my game anymore. I'm going to double all the points. By doubling the points, what am I doing? Multiplying everything by 2. So I'm taking my defined random variable of point value, and I'm multiplying it by 2. I'm multiplying it by a constant, right? So when I multiply by a constant times 2, my new random variable, or my new probability distribution becomes 0. I still have 0, 10, and 100, but all my probabilities are still the same, aren't they? Okay. So go ahead in your calculator and just change list 1 to the new variables of 0, 10, and 100. And what's my new mean and standard deviation? Did you expect that? Because didn't I say if you multiplied by a constant, aren't both the mean and the standard deviation changed? Yep. So we had 20, and then this was 36 point what? Okay. Fair enough. All right. Excellente. Now, the constant stuff seems reasonable. Okay. It seems fairly good. What happens if I want to combine some random variables here? Okay. We already know that. Well, we don't already know. If I have 2 different defined variables, I get points for rolling dice, and I get points for spinning a wheel. So I've got 2 totally different things, okay? And I want to combine them for a total number of points. How does that affect the mean and the standard deviation? Do we understand the question? Let's say it one more time. If I have 2 different random variables, I have points for rolling a dice, so what we just did. And then I have another game over here where we're spinning a wheel, and I have a different distribution for that. And I want to combine them together for a total number of points. I'm going to add them together. If I'm adding 2 different variables together, how are the mean and standard deviation affected? That's my question. Okay? The new mean, well, it's just going to be the sum of the sum or the difference of the individual means. So if the mean of the dice was, what was it? Mean of the dice was 10, and the mean of the wheel was 16, what's the mean of the combined total points? It'd be the 10 plus we'd add them together. Okay? All right. If you add or subtract 2 independent random variables, the new variance is the sum, never the difference. Wait a minute. Independent random variables. What does independence have to do with it? We'll look at it in just a second. Okay? Oh, I'm writing with that. That's not what I wanted. So let me think about this. Spinner and dice, 2 different things, okay? What if I took the same game and I played it twice? Are those independents of each other? Wake up. I'm going to get you out of that chair. Played the game once, came back. I'm like, I'm going to play it again. Okay? It's like me at a blackjack table. I'm coming back. I'm going to win it. Right? Okay? He's right. At the same table, they would not be independent events. I would have to get up, leave, come back, and play again. I agree with you. Or a new shoe or whatever. Okay? Y'all probably don't know what shoes are, but that's okay. It's good that you don't. If we have 2 independent things, and playing a game twice would be considered independent events. Okay? The variance, and we're going to work with the variance, and we'll get to the standard deviation eventually. We're going to have to work with our variances this time, is always the sum. So even if I was trying to find the difference between the point values, your variance is always going to be the sum. That's really important. So if you're going to highlight anything today or circle anything, that would be one you're going to do. Okay? Never the difference. Always the sum. All right. It says standard deviations do not sum, and we'll talk. It has to do with the fact that you have radicals, and if I have like, oops, good grief, really? Just mathematically, real quick. I just did this in my Algebra 2 class. If I have the square root of 10 plus the square root of 5, can I add those together? Right? No, you can't. They don't add. Okay? So you have to leave it like that. So because a standard deviation is a square root of something, right? It's a square root of the variance. They don't add. So in order to combine these, we actually have to square them. We're going to work with the variances. Oh, sorry, 10 plus 5. Add them together and then take the square root. Okay? Huh? Okay. What is the square root of 10 plus the square root of 5? 3, 9. Okay. If I wanted to work with it, so this is going to be a good example. Let me come back to this for a second, okay? Hang on. I'm just trying to figure out a way to explain it to you. I'm not sure that's the right example I wanted to use. We're going to come back. Okay, I promise we're going to come back. All right, I don't want to lose my train of thought. Let's go ahead and, I promise you. Consider the dice game for the previous example. What are the mean and standard deviation if I play twice? Which means that I am multiplying by a constant of 2? No. What am I? Playing twice, multiplying by a constant of 2 would be doubling the points, right? That's what I did before. Playing a game twice, we're going to define it as x plus x. I played it once, and I'm playing it again. Okay? X plus x in the world of random variables, is not twice. They're not the same thing. It's not algebra. Okay? You learn this is to be true in algebra, but not here. Yes?
But this dice game, is the new game considered like when you roll a dice again?
Yes. Yes. Good question, actually. All right, so I'm combining two different random variables. So I want to find the mean and the standard deviation. So the new mean of my variable and the new standard deviation is just going to be, well, 10 plus 10, which is 20. Okay? The standard deviation is going to be 18.03 and 36 point whatever. But hang on a minute. Ms. Macker, you just told me that x plus x does not equal 2x. Okay. Well, when you add them, it does. When you subtract them, it doesn't. Let's go. So let's look at the bottom part. Suppose you and a friend both play. Okay, so me and Sammy, we're going to go to war. Okay, and I'm going to beat you. Okay, we're going to do it. We want to find the difference in our winnings. Okay, different definition here. Okay, how am I going to define that? I'm not playing the same game twice. It's me versus Banani over here. How do I define that? Well, I've played, so I'm an X. I'm not playing the same game again, so I'm an X, he's a Y. So we're going to define it like this. When I played the same game twice, I was X plus X. Me versus him is X minus Y. Okay? So how do I find the new mean and the new standard deviation? What's the mean? Well, what's the mean of playing it once? 10. No matter whether it's me or him, right? So 10, oops, down here. 10 minus 10 is 0. Mean is 0. Okay. What's the standard deviation? 36.06. Why? Because you always add them. Never subtract them. Even though the definition of the random variable, and by the way, I am going to be requiring you to show me this. Define it. Show me this. Okay, so I want you to write it in terms of x and y. Even though we have defined our random variable as the difference in our winnings, okay, we are still adding the standard deviations. Okay? Yes? Okay. All right, let's keep going here. So I want you to read this problem. And I want you to talk to your people at your table. I'm going to sit with Lowly Man over here, and we're going to talk about it. But I want you to read this, and I want you to discuss what possible. And Hunter's going to come join us. You're going to come sit over here. Get out of that comfy chair before you fall asleep. Okay? And we're going to decide what we think our answer is. And whatever table can come up with a good solution to this question, I'll have chocolate for you. Okay? So read. The probability of me being awake, or the number of hours I'm awake versus the number of hours that I'm asleep, are dependent on each other. Okay? We all got that part. Okay? Well, what would the mean of the difference be? Well, it'd be 0. Okay? And the mean of the standard deviation, the spread, would also be 0. Okay? So it's uncomfortable, okay? We can't do any of this combining random variables that Devin's suggesting. Can't do any of that stuff when we have dependent events. And that's kind of the point of this question, okay? It's just we have to test for independent events, okay? Or we have to be told that we have independent events. Otherwise, we can't combine the variables. And that's really the point, okay? That's really, I didn't mean for it to get to be too dramatic, but that's what happened. Right, and I think that was maybe my fault there, okay? So do you understand what I'm asking now, though? The point of the question is you can't start using any of these formulas with your adding, subtracting, multiplying, anything, unless you have independent events. That's really the whole point, okay? All right. How are we doing on time? All right. You what? Oh, y'all get candy. I'm sorry. I'll get it for you before you leave, okay? Kyle's like, all right. So here's probably where we're going to have to end. Okay? Maybe not. Let me see if I want to do this one. Yeah, I think I do. All right. Let's look at this example. So propane tanks, we don't really have, I don't think anybody has a propane heating system here. I have a friend of mine who used to live in Sarasota, Florida, and he delivered propane to businesses and things like that. But now you can just go to Home Depot and get your own darn tank, right? Doesn't matter. Anyway, here's a company that delivers propanes to homes for heating. Most of us have natural gas, I think. The random variable x, and I've defined it for you here, represents the number of gallons required to fill a customer's tank. Okay, so I've defined the variable for you, the number of gallons required. And I'm telling you ahead of the game what the mean and the standard deviation is. That's pretty important, so we're probably going to highlight it. Okay, so x represents the number of gallons, and we have the mean and the standard deviation. Okay, great. A company is interested in the amount a customer will be billed given a particular pricing scheme. Okay? Got two different schemes. I can just charge straight up by the gallon, $2 a gallon. However many gallons I put in your tank, that's how much you pay me. If that's the case, how do I define scheme 1's random variable? How do I write it in terms of x, y, whatever? Is it x plus x? Is it x plus 2? What is it? 2x, 2 times x. We're basically charging per gallon. 2 times x would be the way we would define that variable. I agree. Good job. Scheme 2. This is a different scheme because now I'm charging you $50 just to come to your house, but I'm going to charge you less per gallon. I'm going to charge you $1.80 a gallon. How do I define that, Sammy? Who was your algebra teacher? Dag. Come on, up top. Let's go. Okay, yes, that's true. Okay? $50 service charge plus. Fine, we can do that. This is whatever, algebra easy. I want to find the mean and standard deviation for these newly defined random variables. Plain old X had this, but now I have these two scenarios. Okay, so let's go ahead and do scheme 1 over here. And we define that as 2x. And then we have scheme 2. We'll do that over here. So tell me what the new mean and the new standard deviation are going to be. I just realized I made a mistake on something I did earlier on. We're going to go back to it after this question. Remember how I said I couldn't figure out what I just did. The light bulb went on in my head. I clicked it. What is it? We're going to hold off on the standard deviations for a minute because I did a mistake early on, so we're going to have to come back to this one for the standard deviations. We're going to fix an earlier problem, but we can do the means, no problem. What's the new mean going to be? The original mean was how much? 318, and all we have to do is multiply the mean by that, right? So 318 times 2, so what's our new mean? 606. Thank you for enunciating. So $636. Even, no change? All right, we're going to hold off on standard deviation because I made a mistake early on. Let's talk about the mean. What's the new mean? Let's think about for a second. I am not only multiplying by a constant, I am now also adding a constant. When we look back to the formulas, or look back in the notes, what we talked about at the beginning, when I added a constant, did the mean change? Okay. The standard deviation didn't, though, right? Okay. When I multiplied by a constant, did the mean change? And what else changed? They both did. Okay. So here, we're going to take the mean, multiply it by 1.8, and add 50. Perfect. What is it? What's the new mean? 622.4. Okay. $622.40. Put it in context, right? All right, so I've got to come back to the standard deviation because I made a mistake early on. So I'm going to fix it here, and then we're going to go back and fix the problem before that I made a mistake on. Earlier in the notes, it said that standard deviations don't add. Remember, I was trying to work with Sammy, and I'm going to come back to it. Well, here we are. I have to work with the variances, not the standard deviations. So the standard deviations aren't going to add. I'm not going to add a constant, multiply, whatever. So what I need to do here is I need to work with the standard deviation. So, I'm sorry, with the variance. If the standard deviation is 42, what is the variance going to be? Not the square root. Square. 42 squared. 1,764. Okay, good. That's what I had too. So we're going to work with the variances, and at the end, we'll take the square root. Okay? So let's do the variance first, and then we'll take the square root. I'm going to take that variance of 1,764, and when I multiply, did the variance change? Yes, by that same factor. So what's 2 times 1,064? 3,500.
Only the square root that is the standard deviation. That's the variance.
Yeah,
so
but
the square root of that is 59.20.
I think there's a mistake because I need to look at the formulas in the back of the book. Can you guys look at chapter 16 in the back for me? If you look at the constant, look at page 380. 380. Look at underneath standard deviation on the right-hand side. I have a formula that I need to write down here. It says the variance of A times X is equal to, do you see where I'm looking? A squared times the variance of x. Do you see that formula? You need to write that formula down. I didn't give that formula to you early on, did I? You need it. So what we actually are going to do is not multiply the variance by the number, but we're going to multiply the variance by the square of the number. And that kind of makes sense intuitively because the variance is the square of the standard deviation. Okay, so I'm going to actually multiply the variance not by 2, but by 4, 2 squared. Okay, so this formula is applying to this problem. So I'm going to take it's going to be 2 squared, because 2 is my number here, 2 squared times 1,764. Okay? So when you're multiplying by a constant, you can multiply the mean by that constant, but you have to multiply the variance by the square of that constant. Okay? And what do I get here? Some 10,056 even? And now you're going to do that. You could do it straight up here, but there's a reason why you can't when you add. That's the problem. That's where I was trying to get to you. What, baby? Oh my God. Why? I'm telling you, I blame the shingles. Have I told you my shingle story? I had shingles on my eardrum like whatever, however many years ago, and ever since then I can't hear. It's not you, I blame the shingles. So now take the square root. And Sammy's right. Couldn't I have just done this? And I couldn't have just, yes, in this case you could have. But there's a reason why I'm having you work with the variances. I'll show you why in a minute. What'd you get? All right, bum. All right. So here, we're going to run out of time, darn it. I know, you would here, but when you add them, you don't. So that's where I'm going. I'm headed with this. I just want you to always work with the variances because when you add, it won't work. And I'm going to show you mathematically why in a minute. I'm getting there, I promise. All right, here, 1.8 squared times 1,764 plus, when I add a constant, the variance doesn't change, remember? So that's it. I don't add the constant. Constants don't affect the variation, okay? So what do I get here? It's a kind of crazy number. 5,715.36. And then you would take the square root of that. And I got 75.6 approximately. You square root this number. Did I do something? By 42. Yes, but you got to be careful because when we get to the adding, which is the mistake I made early on, which is why I was remember how I stumbled with Sammy? I'm about to fix it. But it doesn't work when you add, okay? And so that's the problem. It works fine when you multiply, okay? But not when you add. Adding 2 random variables, it does. Adding a constant does not. It's a different situation. Huh? So that's what he's saying. When it's so just process. Let me go back and fix my mistake early on. Okay? So here we are. It's this one here. If we could come back to this problem. Pretty please. Okay? Here's a mistake. This is wrong. Boom, boom. Okay? Because I didn't work with the variances here when I did it. I worked with the standard deviations, didn't I? And I don't want to do that. Because, let me explain why. And this is what I was kind of trying to do with him early on. Okay? If I have 8, whoa, sorry. Come on. Whoa, okay. We have 2 variables I'm adding together. Okay? The variance of x plus x. The variance was 18.03. Well, that's the standard deviations, right? Standard deviation was 18.03 in this problem. What is that number? And that's the wrong answer. Okay? If you cannot just add the standard deviations. Let me show you why. We're going to work with the variances. Okay, these are not going to equal each other. If I take 18.03 and I square it, that's the variance, right? And I add to it the square again, and take the square root of the whole thing, wouldn't that be the standard deviation? What's that number? What is it? That is the correct answer. So, why is that? Well, because the square root of a number, well, square root of whatever, the square root of, I'll just write it in a different color. What, baby?
The decimal would actually be 5. The decimal point after the 9 is 8.
Thank you for being in my life. I appreciate it. Okay, keep me on track. Why is this true? Because 9 squared plus 9 squared, is not the same thing as this. They are not the same thing. Do you agree with that, mathematically? Okay? So mathematically, we understand this. So in order to be able to, because we're talking about radicals here, we're going to work with the variances. We can add those and then just take the square root at the end. Okay? So that was our mistake. So we need to fix it. So we're going to highlight it. We want to be able to do this. Work with the variances. Now, when we were multiplying, Devin and Sammy both figured out you don't really have to worry about that too much. But when it comes to adding and subtracting, you do, okay, because you can't add or subtract radicals. So let's change these values. And they should still both be the same, wouldn't you agree? What are they? 25.5. And we just did the work for it on the other page. Okay? I'm glad we came back to your question, too. That was awesome. Worked out well. All right. Homework. You know there's going to be some, right? Okay. So here it is. Let's see. Chapter 16. I'm going to say chapter 16. I'm going to give you some odd problems because I do want you to check them out in the back of the book, okay? I'm going to say, excuse me, 20, 23, 28, no, because you got to do 15 to do that. I don't want you to go back and do that.
Didn't we do 15?
Yeah, we did 15.
Oh, yeah, you did. 31. And just make sure I'm picking ones that have different things happening.
The last remind notification I got from you was
We'll check it.
2 weeks ago.
And let's do 32. Oh, you know what? I'm crazy. I forgot. I did this already. Look. I already made up the homework assignment somewhere. Here, I did that already. I picked them, hand-picked them already for you. There you go. So,
That's so much more.
okay. So I already did this early on. So write down your homework problems.
Can we go back to what you were just writing now?
Right. I'm picking only A, B, D. I guess that's an F. Oh, plus. Is there an F? I don't know.
It's a plus.
Yeah, it's a plus. I like that better. Okay?